All right, this is Geometry Chapter 8, review for the final. Once again, you'll see objectives on the page, and we're just going to talk about each one in the chapter. Chapter 8 was all about triangles. We did a lot of trig. We used the Pythagorean theorem a lot, so we're very proud of that. Here we go. All right, our objective is that students will be able to use the Pythagorean theorem and its converse. I hope you remember the Pythagorean theorem. A squared plus b squared is c squared. We have a right triangle. A squared plus b squared is c squared. Where A, B, and C are the three sides, A and B make the right angle, and C is the hypotenuse. So in this first one, just find the missing side, leave your answer in simplest radical form. Okay, that's important, that you read it in simplest radical form. So we'll start with this first one. 16 and 12 and x are our sides. You look for the right angle, that's down here, which means that x is our C. So x squared is going to equal 16 squared plus 12 squared. Now all we have to do is just solve for our x value. 16 squared is 256. 12 squared is 144. Together, those make x squared add up. You get 400 equals x squared. And you take the square root of both sides. Square root of x squared is x, and square root of 400 is just 20. So on this one, we didn't have to leave our answer in radical form. It came up to be a nice answer of x equals 20. Let's hope that maybe the rest of ours will as well. So once again, if you look at that right angle, how approximate is that hypotenuse? So 39 is going to be your C this time, which means you have 15 squared plus y squared. When your variable is one of your legs, you want to start by just finding out what all those squares are. 39 squared is 1,521. We don't know what y is, so we don't know what y squared is. 15 squared is 225. Now we want to isolate that y squared. In order to do that, we can subtract 225 from both sides. We get y squared equals 1521 minus 225. That gives us 1,296. Now, we should always double check to see if I take the square root of it, if I get an integer or not. Let's take the square root of both sides. Type in the square root of 1296 in your calculator and see what you get, and hope that you get an integer. And it looks like we do. We should get y to be 36. So that would work out nicely as well. Maybe it will be 3 from 3. Let's see. Once again, look for that right angle. Cross root is your C. 28 squared then equals 20 squared plus z squared. 20 squared, you should remember from the first problem, that's 400 plus z squared. Now, I find it's really easy if I do a problem and come back to it later to lose any z's that I write. So that's why I put that bar through it, so I know it's not a 2. Alright, 28 squared would be 784, subtract 400 from both sides. And z squared equals 784 minus 400, that's 384. Now let's try taking the square root of both sides. Let's see what happens. It doesn't come out to be an integer, it's about 19.595. And so, if this is a multiple choice question, you could just start going through your multiple choice answers and typing in the radical answers that you see to try and get 19.59, but you should be able to pull out some values out of this. I noticed that this ends in a 4, so it's probably divisible by 4, and 4 is a perfect square. So I would just start off with, let's look at that. 484 is divisible by 4, so what we could really do is split that up into whatever 4 times whatever is 96, 4 times whatever is 384, 4 times 96 is 384. Alright, so let's look at that 96. 96 to me, it might be divisible by 4, I need to check it. It is 4 times 4 equal to that. It's 4 times 4 times 24. The 4 times 24 is the 96. What I might do at this point is start to kind of pull out some of those values. Well, 4 times 4 is 16, and the square root of 16 is 4, so I'm going to pull out a 4 out of this entire thing. I get 4 times the square root of 24. Now the square root of 24, more can come out of that. You can actually pull another 4 out of that. So you get 4 times the square root of 4 times 6. Now the square root of 4 is 2, and so when we pull that out, you're going to multiply that 4 out in front by 2, and we get 8 root 6. 6 factors of 6 are 3 and 2, so nothing else can come out. That means that in this case, z equals 8 root 6. If you want to double check that, type it in your calculator. I got the same decimal, 19.595. So that must be what my answer is. Be careful in simplifying radicals that when you pull something out of the square root, that you pull out the square root of it, not it. That was our biggest mistake that we made when we did these. So the converse of the Pythagorean theorem is this next part. And the converse of the Pythagorean theorem basically states that if a squared plus b squared is c squared, then you have a right triangle. If not, then you either have an obtuse or an acute triangle. So what you first want to do is you want to set up a squared plus b squared is c squared. Well, when you have 3 side lengths, you always have to look for the longest one, and the longest one here is 15. The longest one is going to be your hypotenuse c. So 15 squared would be where your c goes, and do 8 squared plus 11 squared. Now, I like to put a little question mark between them, because we don't know if they're equal. The goal is to figure out what is the relationship between those two sides. So now we start to evaluate. 8 squared is 64, 11 squared is 121. Add them up, you get 175. 15 squared is 225. Well, obviously, these two values are not equal. You can tell that. So we want to think about a squared and b squared. Are they less than or greater than that 225? They're less than. Anytime that c squared is bigger, that means you have an obtuse triangle, because that means that the square by hypotenuse is longer. And so in this one, we're actually going to have an obtuse triangle. I want you to pause the video here and try the next two on your page. When you finish them, press play and check your answers are fine. Here are my solutions. You can see in the second one, I got 1,681 on both sides. That meant that they were equal, so you have a right triangle. On the third one, I got a squared and b squared to be bigger. 365 is greater than 361. If a squared plus b squared is bigger, that means you have an acute triangle. So that would be those ones. Alright, we'll go to the next chunk. Our objective is that you'll be able to use the properties of 45, 45, 90, and 30, 60, 90 triangles. The one thing you want to remember are those ratios. For 45, 45, 90, it's 1, 2. For 30, 60, 90, it's 1 square root 3, 2. So if we take a look at the first one, it says find the missing side lengths. If your answer is not yet, generally it in simplest form. If you look at this one, we have a right angle and a 45. Using the fact that all the angles in a triangle at 180, you can find that third angle to be 45 degrees as well. Now, if you look, what they gave us is 20, which means they gave us the hypotenuse. So in your ratio 1, 1, square root 2, they gave you the part that goes with the square root 2 typically. So if we want to move backwards from the hypotenuse to a length, what we have to do, rather than multiplying by the square root of 2, we divide by the square root of 2. So we're going to take 20 divided by root 2. Now, if this is a multiple choice test, that's not going to appear here in your answers because we don't want to divide by the square root of 2. So to get rid of that, we multiply the whole thing by 1, which is the square root of 2 times the square root of 2. It's the same thing top and bottom, so it's technically 1. Why we do that is because the square root of 2 times the square root of 2 is really the square root of 4. Multiply the pieces underneath. Your 20 root 2 over square root 4. So we know what the square root of 4 is. It's 2. So 20 root 2 over 2. Now we can simplify that 20 over 2 to get 10 root 2. Now, if you think about that ratio, 1 and 1, those are the exact same values. The legs in a 45, 45, 90 are the exact same values. X and Y are our legs, so X equals 10 root 2, as does Y. There we have the first one. This next one is also another 45, 45, 90, so your third angle. But what they gave you is a leg, and we know from the last problem that the legs are the same, so right off the bat, you should know that n is 7. Now, the way that you go from a leg to a hypotenuse is you multiply by root 2. Because to go from a hypotenuse to a leg in the last problem, we divided by square root of 2. We do the opposite. So if you take an integer and you multiply it by the square root of 2, 7 times root 2 is just 7 root 2. Which means m is just 7 root to personally, I like to move back and forth from the leg to the hypotenuse better than I like to move from the hypotenuse to the leg. These two are both 30, 60, 90 triangles. So here, I know that they're both 30, 60, 90 because I have a 30 and a 90. 30 plus 90 is 120. You need another 60 degrees to get to 180. The ratio for 30, 60, 90s is 1 squared root 3, 2. And so it goes small, medium, large. You want to find the smallest side or the largest side typically first. So if you look, the smallest side is going to be the angle, or is going to be the side across from 30-degree angle. So if you look at these labeled angles, 30 degrees and 60 degrees, these are labeled poorly. This triangle should actually look more like this, with A, B, 9, 30 degrees, right angle, and 60 degrees. So don't always trust the picture that you have. It could be deceiving you. And so our small side should be B, which means that 9 is our medium. Now, I don't always teach you want to give us the medium as an integer, because in our ratio, the medium side has a square root of 3. So now what we have is we have a 9 for that square root of 3. Now there's two ways you can go about this. To get from the square root of 3 the ratio back to 1, you divide by root of 3. And if they give you the medium side, that's typically your best bet of where to start. So if we take 9 divided by root of 3, just like the previous problem, we don't like to have a radical square root of 3 and a round here. So we're going to multiply by root of 3 over root of 3. We get 9 root of 3 over the square root of 9. Square root of 9 is 3, so we have 9 root of 3 over 3. This is a nice one because we can actually do 9 divided by 3. And that gives us 3, so we have 3 root of 3. This is our small side. So our B actually is going to be 3 root of 3. Now, you always want to find the smallest side first, because from the smallest side it's really easy to get to the medium and the large. The smallest side is 1, the large side is 2, which means it's double the amount. So you're just going to take 3 root of 3 times 2. So to get over A, you have to go 3 root of 3 times 2. Well, you want to multiply the integers 3 and 2. 3 times 2 is 6. You get 6 root of 3, and that's all it is. This next one should work out a little nicer because they didn't give you the medium side. I'd like you to pause the video and try it on your own. Alright, you can see my answers down there in my green box. I'll box it in again in blue. I got Q to be 21 and R to be 21 and 3. You can kind of see my work. What I knew was the 42. I worked backwards to get to the small, and then I used that to find the medium. Alright, we've got 3 more learning objectives left for this chapter, so let's keep going. Here's the next one. So objective students will be able to use the sine, cosine, tangent ratios to determine side lengths and angle measures in right triangles. It says find the missing values in the nearest function. You may remember back in our test from this chapter that when they had a problem like this, they would say sine and have a box equals 5 and 15. Or they have a box where they have an x right there, what they're looking for is the angle measure. And if you remember from sine, cosine, tangent, if you have the sides and you want the angles, what you have to use is actually sine, cosine, or tangent inverse. And so what we're going to do is we're actually going to say sine inverse. We're going to rewrite this of that side length ratio, 5 to 15. And that's going to equal our x value. Now, to figure that out, you're going to need a calculator. You need to make sure your calculator is in degree mode. And so if you go to the mode button on the top, the third line down should have 2 options, radian and degree. You want degree to be highlighted in the black box. If it is, you're good to go. You can put it out, and you can type in sine inverse. Make sure you're doing sine inverse of 5 over 15. The directions say run to the nearest 100. If you're running to the nearest 100, that means 2 decimal places. So we're going to have 19.47 equals x. Alright, pause the video and try the next one. One thing that you want to make sure of is x is talking about degree measures, so make sure you have those degree symbols with both of those answers. You should get x to be 66.42 degrees at the top. So you need to be able to use sine, cosine, tangent inverse to find the same angle measures, but you also need to be able to write the ratios for sine, cosine, and tangent And so this is where TOA is in place. Sine is so, that's opposite over hypotenuse. Cosine is ca, that's adjacent to hypotenuse. And tangent is TOA, that's opposite to adjacent. And so we're going to go with sine of angle A. Let's go mark angle A. It's the opposite side over the hypotenuse. So sine of A equals the opposite side 24 over the hypotenuse 25. That's all they want. You don't have to do anything more than that. Because all they want is the ratio, that's the ratio. So now we're going to do the same thing for cosine of A and tangent of B. Make sure you're using tangent of B, not tangent of A. Positivity or finish those. Alright, check your answers. Mine, cosine of A should be 7 over 25, and tangent of B should be 7 over 24. They changed the angle on you there from A to B. Make sure you change the angle as well. So this next set says find the value of y round to the nearest 10. So now we're actually going to use sine, cosine, tangent ratios to actually find some missing values. So if we look at this first one, we have 41 degrees. So if we want to start with that 41 degrees, you want to look at those two sides relationships with that angle so you can determine which trig function to use. And if you look, y is opposite and 18 would be the hypotenuse. So TOA, well, sine uses opposite of hypotenuse, so you're going to say sine of the angle. We actually know the angle measure this time, so we can plug it in. That's going to equal the ratio of the opposite to the hypotenuse. So tells you the order for your ratio as well. It's opposite first, then hypotenuse. Our opposite side is y and our hypotenuse is 18. When your variable is on top, it's a really easy fix. Get rid of that 18 by multiplying both sides by 18. And y equals whatever 18 times sine of 41 is. You want to type that in your calculator, 18 times sine of 41. And you should get y to be 11.8. If you are considering the nearest 10, so I rounded it to the right spot. Now if we set up the next one, we have 53 degrees. We have an adjacent side and a hypotenuse side. That's cosine. So we want cosine of 53 equals the adjacent side to the hypotenuse. Now when the y is in the denominator, we've talked about all the work to solve for that variable. But what ends up happening in the long run is the y and the trig function, they switch places. So y equals 9 over cosine of 53. So make sure when you're typing this in your calculator, you're doing 9, the divide symbol, cosine of 53, and that should get you the right value for your y. You should get y to be 14.954, and if we're rounding that to the nearest tenth, that actually rounds to 15.0. Because we rounded that, you would put, and we're rounding to the nearest tenth, you would actually put that 0 for the 10th place in there. Otherwise, it's telling me you were probably maybe just rounding to the nearest integer, you weren't paying that much close attention to the problem. Put that 0.0 so I know that you do know that it's the 10th and that value should be accounted for. All right, next page. You've seen this picture before, but now it's just modified a little bit for this problem. The objective on this page is that students will be able to use the sine, cosine, tangent ratios to determine side lengths and angle measures in right triangles. I'm going to do a pause the video and see if you can do this without any instruction, and then go back and check your answers with me. So pause the video now and see what you can do. Alright, you can see my work up there for this one now. I set up tangent because I got opposite and adjacent sides. The opposite side was the height of the tree that I was actually looking for. I got tangent of 38 to equal x over 72. Multiply both sides by 72 and you have your x on its own. So I typed in 72 times tangent of 38 in my calculator. I got 56.25, that means the height of our tree is 56.25 feet tall. And that's it. Make sure that your answer has that label, feet tall, because this is a context problem. Now in the next two, if you tried those, way to go. If you didn't, that's okay because they were using sine, they were solving for angles you hadn't done yet this video. So what we want to do is we first have to identify which trig function we're using, sine, cosine, or tangent. So identify the opposite and the hypotenuse side of this first one. That means I'm going to be using sine. And what I'm looking for is the angle. If I'm looking for the angle, I want to use the inverse function. So I have the sine inverse of 7 over 12. That's going to be my x. So x is 35.69 when I type that in. But the directions say around to the nearest degree. When I round that, I actually end up with x being 36 degrees. Set up the same, the next one's going to be similar. I have my angle, my opposite adjacent side, which means I'm using tangent, I'm using tangent inverse, because I'm looking for an angle measure. I go 4/7, and I got 29.74, which rounds to 30 degrees on this one. Pretty straightforward. Next page. We're going to go pretty fast through these ones. I want you guys to actually see these problems before. So draw a picture and see if you can find what they're looking for, and then press play to check it. Pause the video now. So I drew a picture to go along with this one. You can see my ground is this horizontal line, my wall is that vertical line, and my ladder is leaning up against it. The wall and the ground should make a right angle and do that in, and I took it in all my angle and my sides. And I'm realizing that sine is the trig function I needed to use. I got sine of 63 equals x over 6.7. Well, I will sine by 6.7, and x is 5.9 meters. They don't tell you what to round to, but luckily the 5 is also twice, so look for your whatever is the closest to your answer. They don't tell you what to round to. On the next one, the picture is kind of tricky. So you can kind of see my picture there. The blue wavy line would be the surface. So if you have a submarine that was at the surface, your submarine was here, and then it's going to dive down to here. It travels on a path at an angle of 21 degrees with the surface. So the surface, my blue squiggly line, and the green line together make that 21-degree angle. It goes for 300 meters along the downward path. That hypotenuse of this 300 meters, the green path that it travels. The question is, how deep will it be? Well, I solved for the depth in the red with y. I solved for the horizontal distance in the purple with x. And so if you're doing first the depth, you have to use sine. Sine of 21 equals y over 300. You should get y to be 107.5 meters. Now, I assigned y to be the depth. What I want to then clarify is how deep does it go? It goes 107.5 meters deep. Okay, and then what is the horizontal distance from its starting point? I identified cosine as the function I wanted to use. Cosine of 21 equals x over 300. Multiply both sides by 300, and x came up to be 280.1. So the horizontal distance, you want to specify that? The horizontal distance, I abbreviated a lot, is 280.1 meters. So you would need to clarify to that level in a problem like this. Because they're asking you for two parts, and once you specify, they don't know which one is which, so make sure that you do so. The last page in this chapter was on vectors, and so it's pretty basic vector stuff, but the objectives that you'll be able to describe vectors in a vector direction. And so to describe each vector as an ordered pair, round to the nearest tenth. Okay, and so what you want to do is you want to make a triangle. And so if I know that 28 degrees is the single right here, I want to bring up the end of that vector up to the x-axis because that angle is made with the x-axis. The reason why is because that then creates a right angle, and now I have a triangle, a right triangle. With an angle of 28 degrees, and this 42 is actually talking about the length of my hypotenuse. And so if we're going to describe each vector as an ordered pair, we need an x value and we need a y value for this. The x value is your x-axis value, your horizontal distance, and the y value is your y-axis value, the vertical distance of that endpoint. In order to find that, we can use our trig functions because we have one side and an angle in a right triangle. And so I usually start with my x. X is adjacent to that 28 degrees, and 42 is the hypotenuse, which means I want to use cosine of 28 by my x. That's going to equal my adjacent side over my hypotenuse. Now to solve that, I multiply both sides by 42. And I get x to be equal to cosine of 28 times 42. X equals 37.08, which becomes 37.1. Now, when you're writing a vector order pair, you have to think about the positives and negatives. So if we look at what remember that endpoint of that vector, the tracing in black right now, that's in the third quadrant. And in the third quadrant, everything is negative, which means you have a negative 37.1. And whatever our y value is, we're also going to make that negative. So now we want to set it for our y value. That's our opposite side. Or we know our hypotenuse, 42. So we're going to use sine of 28 equals y over 42. Multiply both sides by that 42. And we get y to be equal to 19.717, which becomes 19.7. So now when you put that into our answer, remember it should be in negative because they're in the third quadrant. The nice thing about vector problems is they may not be the easiest to do, but if you just think about running over pairs, and this is multiple choice, you can eliminate a lot of questions right after that. So pause the video and try the next vector question as well. You should end up on this one with X and Y doing the same thing, which makes sense because this would actually be a 45, 45, 90-degree triangle. And so those two legs should be congruent. Solve them both and you get 45.96 something, but that's going to round to 46.0. We round the answer to the nearest 10. So basically, you want to make a right triangle if you're trying to describe its vector as an ordered pair. And think about the positive and negatives. I didn't have to worry about negatives for the second problem because I'm in quadrant 1 and everything is positive in quadrant 1. So the next level of vectors you're going to be asked to do is be able to actually find the compass directions to describe a vector. And so the way that you do that is you look at the angle that is made by the vector and the axis that is connected to it. And so we say that that angle degree is 55 degrees, and we're going to say it's something of something. The second point is the axis that it's attached to. And so it's attached to the east axis. So we want to put east second. And the first point is, well, is it, it's the other direction that the vector goes. And so it's going a little bit north of east, and so we would say 55 degrees north of east. So for the second one, we look, okay, 20 degrees is talking about this angle here. So we have 20 degrees. It's attached to the south axis, so it's something of south. Well, your options are either to the east or west of south, and you can see that that vector moves west of that south, and there you have it. This is the end of the Chapter 8 Geometry Final Review. Feel free to go back, look through stuff. I'll post my work on the Schoology as well, so you